Hey everyone, and thanks for tuning in again. In today's video, we'll be covering how to transform non-normal data. So, normality in the dependent variable will often be associated with non-normal residuals, and this violates one of our regression assumptions. As a result, this yields problems for inference. So, to try and eliminate non-normality, we can try and apply transformations before an analysis. So what we'll do in today's lab is we'll examine the skew and kurtosis of the variables in the regdata3 dataset. This is the dataset that we used in the last video. If any of these variables exhibit relatively large values for skew and/or kurtosis, we will try applying two different transformations. First, the square root, and second, a log transformation. And we'll be using the natural log, which is the default in most software. After transforming our variables, we will check for improvements by recomputing our descriptive statistics, where we'll look at the skew and kurtosis values, and by visually inspecting the transformed distributions using histograms. Before we get started, just want to make a note on interpretations. Remember that the standard interpretation for a regression coefficient is the expected change in y given a 1 unit change in a predictor controlling for all other predictors. This changes when variables are transformed because the units of y have changed. So instead of speaking in terms of a beta unit change in y, we will now be talking about a square root unit change in y, or a log unit change in y. Because it's not just in the units of y, but it's now in the square root of the units of y, or the log units of y, or whatever transformation you may be applying to your data. So just remember that the interpretation will change and become a little bit more messy when you transform your variables. And with that, let's go ahead and get started with the lab. Okay, so here I have SPSS open, and by default it just opens up to a blank data set. And so I'm going to go ahead and first open up my SPSS data set. So I will go to Open, Data, and then again I store all of my data sets in the C drive, in the Datasets folder, and today we'll be working with regdata3. So go ahead and open that. I'll bring in the data set here, and then here's the output viewer. Okay, here's the data set. We have x1, x2, y1, y2, and y3. We saw these variables in the last video, and then we have 150 observations. So again, same data set from the last video. And so before we start transforming, we want to check to see if there are any variables that are problematic. So are there any that are highly skewed or highly kurtotic? So what we're going to do is we'll start off with descriptives. So we're going to analyze descriptive statistics, select descriptives, and then I'm going to hold Shift and select down to Y3 so that all of my variables are selected. I'll put them in the variables box, and then under options we want to make sure we have the things that we want. So the mean, standard deviation, minimum, maximum. Typically I'll select variance. And then most importantly for our purposes today, kurtosis and skewness. We'll go ahead and click continue, and then OK. Alright, so what we're looking for here, again, a rule of thumb is any values of kurtosis or skew that are greater than 3 or less than -3 are problematic or cause for concern. But in my experience, skew that goes a bit past 1, maybe 1.2, 1.5, that starts to be a cause for concern. So those are the values that we'll be looking for here. So if we go to x1, skewness right here, nowhere close to 3, and then kurtosis, nowhere close to 3, so we're good there. x2, same thing, nothing close to 3. Nothing close to 3. Same with y1, all good here, and all good here. And then we get to y2, and skewness is getting relatively larger compared to the other values here, but it's not too bad. But kurtosis is clearly above 3. So let's go ahead and keep a mental note of y2. And then when we go to y3, same thing, skewness a little bit high relatively to the other values, but kurtosis is not close to 3. So I wouldn't worry about y3 that much, but we're going to go ahead and look at and focus on y2 here, because skewness is at 1.27, relatively higher than the other values, and then kurtosis is greater than 3. Okay, so first what we'll do is we will plot a histogram of y2 to take a look at the shape. So we'll go to Graphs, Legacy Dialogs, and down to Histogram. And then again, I want to take a look at y2, and then I'll click OK. We saw this graph in the last video, and again we have an observation out here, and it does seem to look positively skewed, with this observation pulling the tail to the right. So I think this is enough for us to go ahead and proceed with transforming the variable, just so we can try and get it to look a little bit more normal, so we don't have to worry about the distribution of our residuals being non-normal. So to transform, actually before we transform, if we take a look here, so we're looking at y2, and if we take a look here, the minimum value is negative 2.92. The two transformations we'll be performing are the square root and the log transformation. But because they're negative values, that will be a problem for square rooting and for taking the log. So what we'll have to do first is we'll have to make a new y2 variable where they're all positive numbers. So all I'm going to do is add, since this is negative 2.92, I'm just going to add 3 to all of the observations, which will make all of them positive. And so we will get rid of all of the negative values. So let's start there. So I'm going to create a variable called, let's do that one more time. So we'll go to transform, and then we'll go to compute variable. And I'm going to create a new variable called y2 new. And so I'll take y2, and then I will put it in the numeric expression box, and then I will simply add 3. And this will get rid of all of the negative values, since our minimum value is negative 2.92. I'll go ahead and click OK. And then if we go to our data set, here we have y2 new. So if you look at y2, the original one, it's 0.28 with rounding. And now it's 3.28 for y2 new. The second observation is 1.62 with rounding, and the new observation is 4.62. So if we add 3 to all of the observations here in y2, we get y2 new. And again, the reason why we did that is because our minimum value is negative 2.92. So adding 3 to everything will make everything positive, so that we can square root transform and log transform. Okay, so let's continue with our transformations. So we'll go back to compute variable, and this time I'm going to call it y2 root. And what I'm going to do is take the square root, so sqrt, and then in parentheses goes our variable y2 new. Now be careful here, make sure it's y2 underscore new. If you take the square root of the original y2, it won't work for negative variables or negative values. Same thing later when we do the log. So make sure it is y2 underscore new in the parentheses here for the square root function, which is sqrt. I'll go ahead and click OK. And if we take a look at our data set, we should have a new variable called y2 underscore root. And so if you take the square root of all of these values here under y2, we will get the corresponding y2 underscore root over here. Okay, and then our last transformation, we'll go to compute variable one more time, and I'm going to call this y2 underscore log. And all we have to change here is this function, and we'll change it to ln. We want to take the natural log, so that'll be ln. And then again, in the parentheses, make sure it's y2 underscore new. So that all looks good. I'll go ahead and click OK. And then if we go back to our data set, we have y2 underscore log here, our new variable. So again, if you were to take the log or the natural log of each of these values here under y2, you would get these corresponding values here. So to summarize, we created our y2 new variable by adding 3 to every observation so that we get rid of negative values. And that allowed us to square root transform our y2 new variable and log transform our y2 new variable. Okay, and remember, what we're trying to do here is we're trying to eliminate skew and kurtosis so that we don't have to worry about our residuals, the distribution of our residuals being non-normal. Because remember that if our variables are non-normal, then the distribution of our residuals can very well be non-normal as well, or 2. Okay. So what we're going to do now is we're going to check the descriptives of our new variables. So we'll go to Analyze, Descriptive Statistics, go to Descriptives. I'm going to go ahead and just pull all of these out here. So I'll hold Shift, click down to Y3, and then what I want to see in here is our original y2 variable and then the transformations, y2 root and y2 underscore log. Click on Options just to make sure everything is still selected. Yep, and then kurtosis and skewness. That's what we're focusing on, and then I'll go ahead and click OK. So remember, for our original variable, the skewness was 1.27 and the kurtosis was 4.05. Okay. If we look at the square root transformation, skewness is almost 0, which is good. And kurtosis is under 3. It's now 2. So that's also good. If we look at the log transformation, on the other hand, it actually made things worse. So that's a larger value, or I guess less, but it's approaching 3 now, but in the other direction. And then here, it's much more kurtotic. So transforming is kind of like a trial and error exercise. There are many different kinds of transformations, and the goal is to find one that works for your variable and helps eliminate skewness and kurtosis. And so what we'll do here is we'll just go ahead and we'll ignore the log transformation since that didn't work for us, and we'll focus here on the square root transformation. Okay. And so the last thing we'll do is we'll go ahead and plot the new distribution of y2 after the transformation, and we'll take a look at how we did here. Okay, so we have y2, so we're going to go ahead and take this out, and then go to y2 root, and then we can click OK, and there you go. So this is how our distribution looked before, with this one observation pulling the tail to the right, making it positively skewed. And then here, we have a much more normally distributed looking variable. So putting this in our analysis, the square root transformation of y2, will result in a little less worry that the distribution of our residuals will be non-normal. Because our outcome variable is normal now. Okay, and then again, just remember the interpretation will change because now y2 is not in its original units. It is now the square root of y2. So it is in square root units of the original metric. And that is important to note because your interpretation will change. So it's no longer the expected unit change in y, it's now the expected square root unit change in y. Okay, and with that, that concludes this video on transforming non-normal data in SPSS.